Hi, welcome to a new video dedicated to the new brushed racer from Eachine. This is a QX110 and this model comes after a series of former model, and this one is introducing a lot of new novelties. First of all, in terms of design, it's using a V-tail architecture, and if you don't know what is a V-tail, it's a special way to form the rear arms with the 45 degrees of inclination, and in theory it should offer much more radar authority in your fast turns. More in terms of electronics, this new compact brushed one cell model is introducing also a full omnibus flight control board with an F3 board, F3 processor, and with Beta OSD chip built-in one, so you will enjoy some OSD information in your FPV. And the FPV part is a classic IEO 25 mW 48 channel, the same module than the former model. Okay, and what I can say, there is also a buzzer, that's great to localize your lost quadcopter, and some different nice elements. So let's discover the content of this new brushed machine model. Okay, so let's open it. First of all, you will find this nice instruction manual printed in color. That's great. The same where you will find all the instruction manual to bind the three different type of receiver, okay, associated with. Mine is the FieldSky G8 version with the working telemetry. At least I will check that the telemetry is working, but you have also a DSM2 DSMX for Spectrum radio, and the last choice is the FlySky, I guess compatible with the FDS2 protocol, so compatible with most last recent FlySky radio. Okay, so you will find all the instruction, and especially here you have the list of all supported 48 channel 6 band. Okay, the front button to set your NTSC or PAL, okay, and the rear one more to select your current VFREC and VBAN. So the last is associated with your OSD configuration and your LED bar, because you have also LED bar programmable. So let's discover a little bit the accessories. You have 3 Velcro band, okay, 2 are locked to secure more your battery. You have here USB charging cable ending with a micro LOSI, the same for all the QX. 2 rubber band, okay, to secure maybe your battery installation. And what also I will find here, it's a doubler to charge in parallel your 2 LiPo battery. Here are the LiPo battery. You will recognize them exactly the same 601 cellule model. Okay, no voltage protector, but they are quite good. Each of them weighs approximately around 16 grams. Okay, let's scale that. 16 grams to be more precise. It's always nice to have a spare battery, and the exact dimension, if you need some, it's around 45 by 25 by 8, I will say, in first approximation. So nice to have both. What you also will find a bag with 4 spare props, 2 red and 2 black, okay, and you have here also some element is to secure the taping of the IO camera. It's good to have a spare one, and a wrench remover props tool, always nice. So the props are 55 millimeters, if I'm not wrong. I will give you the exact dimension if I can. Okay, they are more or less, yes, 55 millimeters. The classic one, they offer good trust. That's a pretty good props, I like it. So now let's discover a little bit the machine. Okay, and here is so it's a 3-key carbon based, but as you can see, the front arms, you have a huge central hole, and the thickness should be not super fantastic. We have 1mm50. So what's happened in case of frontal crash? I'm afraid that the arm will break. Okay, so the main question is, the lower frame can be replaced easily without disassembling everything. Should be okay, but please things to stock at least a one lower frame in case, and since there is no prop guard, I don't strongly advise to fly it more indoors, especially if your ground is based on very hard surfaces. Okay, no prop, because you will probably break more easily the arm. Okay, so we have some plastic motorboat jailing the 8.5 millimeters, yes, by 20 coreless, brush coreless motors. No exact performances about them. I hope they are strong. Okay, so we have on top the bother, you can see here, protected by this upper X frame, maybe not ultra necessary, so if you want to remove some weight, you can remove this upper elements. Okay, and here we have installed on the parallel of the frame the antenna, so it's not really good for the FPV propagation, so it's probably for the transportation, but please think to bend it gently to not break the connector. Okay, to raise it vertically to extend your FPV range. We have the I/O camera, the 25 milliwatts, 48 channel. So the front button here is to select between NTSC and pale, and you can also flip or mirror your image if you short press on it. The rear one is more to select your current VFREC inside the current V band, and if you long press on it, you can select cycle between the 6 band supported band. The raised band is obviously supported. So we have the Omnibus F3 board here, including a Beta OSD chip. You can maybe guess it, it's a long one, long elongated, just behind the micro USB plug port here. Okay, so that's great. The micro USB port is very easy to access. You have Betaflight 3.01 installed with the LEDs more or less well configured. The USD, we have the default settings, but we will see that we have some optimized PID settings on them. We will see. We have on the rear attached through this cable the 4 LEDs light programmable through Betaflight. So we will have by default scanner Larsen effect. We will see that. Okay, blue, and you can see the Night Rider effects, Larsen scanner, that's great. Some lights for the I/O camera, and here we have a blue light associated with the flight control board. Okay, if you arm, and on front, the green here is for the receiver. So we have on front, for the physical activation at least, a bind button, so no auto binding procedure like some recent physical receiver. The trick is to power while pressing this button to enter into bind mode. I will of course show how to bind with your my compatible FieldSky G8 radio. So one word about the I/O camera, I forgot to mention, you can adjust the lens orientation. That's great. We just need to release these 2 lateral screws here, and you can adjust a positive, more aggressive positive angle. If you are more an acro flyer, I will do that. So you can probably around adjust between up to 20 degrees. That's great. So let's check now the more interesting in terms of design. The V-tails, as you can see, we have an angle. Okay, and everything is based on this central plastic. You can see here this U-range one, and it's the arm seems to be independent, locked to this U-range. So probably if you break a rear arm, it will be more easy to replace just by them independently. Sounds to be a good idea. And look that each motor are plugged through 1.25 GST micro GST connector. So that's great for motor maintenance. Everything on every connector easy to connect. That's great for in general for maintenance. Be aware, here all the electronics are available, so maybe you will need to protect it with a liquid electrical tape, or install the this type of tape, okay, a Velcro band to protect and to secure the battery installation. So be sure to be aware if you are flying over grass, wet grass surfaces, okay, to protect this zone. So we have 45 degrees of inclination, still 1.5 millimeters in the rear side. It inspired me a little bit more confident that the big larger model, the Eachine V210 was a real fiasco. Here I feel more confident. Okay, so I'm not so afraid that this part will break. That's good news. So a lot of positive points. Okay, let's measure a little bit the weight of the system. So I will scale everything. So this model comes after the BAT QX110 with some 10 millimeters 20 coreless motors, and this model the associated MOSFET on the flight control board was not strong enough to support to feed this stronger motor. So, and the weight was closely very important. Okay, so we will check if with the 8.5 millimeters by 20 coreless motor solution we will gain some weight. Yes, it's true. So 45.9 gram without the battery. So with we should reach a little bit more than 60 grams, 61.7. And okay, let's add why not a Velcro band, something. We will be under probably 63 gram. Okay, 62.9 gram, and it's around 15 gram more lighter than the BAT version. So, and I think it's much a better option. It's a better good news because it should be much more powerful, and the associated FET will be able to handle much better this the requirement in depth of current. Okay, so I am not so afraid to burn a MOSFET during mid-flight. And now I want to show you, after the overview, I want to show you how to bind this machine, at least for the FSky version. Okay, the trick to bind is first to pre-insert the battery, but not fully. Okay, just before the fully connection. Okay, then press the bind button on front, and then continue to fully insert the battery. Yes, it's not okay. It's not perfect, and it didn't do it perfectly. Okay. Okay. Then on your radio, press your bind button. And after a couple of seconds, the light should be turned off. So let's check that. We have to turn off everything. Okay, replug the battery. Okay, so we have a flashing LEDs. Now I will bind, and we got a solid green LEDs. So we will check that everything is okay. Let's check the telemetry information. We have some signal, okay, some battery here, some MISC, and some value here. So I guess the RSSI at least is transmitted, so that's great. Okay, welcome to the Betaflight default configuration. So I will connect and immediately perform a dump of the system. Okay, so you will be able to see that the default version is an Betaflight 3.0.1 for Omnibus F3 board. So to copy all information and to paste it into a text file. In case you can restore all the default settings. Okay, so it's great, and let's continue now to discover a little bit the setup. So we will reconnect again. You can hear the buzzer, and immediately you can see the general details architecture. So let's check the port. We have USB VCP, okay, enabled, of course, for the Betaflight configuration. The UART1 is also in MSP mode, and for the built-in FSky D8 in S-Bus connection, we have the serial turned on for the UART3. So let's now check the configuration. We have a detailed quadcopter. Okay, so look the number of the motors. We have brushed, of course, motor stop, so if you don't want, and we have a mid throttle. Okay, maybe a little bit high, so if your model is jumping a bit with the throttle, maybe you have to decrease this value. No specific alignment for the board. Okay, S-Bus connection, said previously, so serial turn on and S bus selected. VBAT, okay, we will see if these values are okay for the 600 milliamp hour LiPo. Good, 4 kilohertz for both gyros and PIDs, that's great, so no adjustment. And telemetry is turned on, very important to transmit your information to the OSD and to the FSK G8 transmitter. Let's strip because they are primate bow, and the OSD is turned on, that's great. Let's check the fail-safe is turned on with the drop option, that's great. And look at the PIDs. So we have the Betaflight PID controller. We have some specific, the p-value of the yaw is very low, okay, high value for the integral, and the derivative also is important, okay. The accelerate also not a lot of velocity in terms of angle, so maybe it's not a super acro flyer, so or you will have to increase these values if you want to perform some faster flips and roll, okay. The strengths also have been optimized, it seems to be, okay. And let's check the TPA, nothing special is done. The receiver, okay, I will turn on my radio. Okay, so you can see that for my radio I'm not on the right channel mapping, so I will use more the Aaron first. I will save, will stop to rotate, and it's very important that the RSSI is transmitted on channel 9, okay, so don't forget that. But everything seems to be well centered, okay. Let's check the default in my radio. A 2-way for AUX2, I will be associated for the better for me, and a 3-way for AUX1. So let's check now the default flight mode. We have, okay, so by default we have, first of all, it's an angle 1, so I will first much more assign the beeper on auxiliary 2. I will save. Okay, now is look that the buzzer is not super loud. I'm not super impressed by this buzzer. And now let's check more the flight mode. So when your flight mode switch is in up position, you are in acro. So be aware of that. Okay, you are in acro. And when you are in the middle, you are the 6-axis stabilization is now turned on. And when is on the bottom side, the third position of 3-way, no specific change. Okay, so I will more apply my personal. So I like to arm with the left switch, but some people prefer to arm with the switch. Okay, so I will disable everything. I will apply an angle mode, okay, like this, then an horizon mode, and then I will apply air mode for both the horizon and acro. Okay, so it's my favorite. Okay, now when I'm in horizon, I've got the air mode turned on, and in pure acro, air mode is turned on. Okay, so sounds to be a better adjustment for me. And now let's check the OSD information. So I prefer to fly in pale, so be aware. So I will select pale. Okay, I will select the metric, and we have to adjust a little bit more the capacity of the battery. We have a 600 mAh. The flight time we will say around 5 minutes, okay, to be sure, and we will say that. Then now we will remove a lot of elements in the OSD. We will leave the crosshair, but the artificial horizon we will remove it. The horizon sidebar we will remove it, okay. The aircraft 9 we will remove it, okay. We now will be adjust more the elements, okay. Flight mode, and the flight time here, as well as the RSSI, and we will also have the throttle values, throttle position, okay, here, and we adjust in the middle here. Okay, so now I have all the information on the bottom, okay, and we have to save. So be aware, since I selected the pale, you have to turn the pale setup in your I/O camera. In terms of LED strip, the default, we can see that the left one we have a Larsen scanner, and it's effectively an indicator indicating the left direction. We will see the right one, the third, and we have also Larsen scanner effect turn on and indicator. And let's see the central one. For the one we have here a Larsen scanner, and here we have here this color modifier turn on, as well as the same, okay, for the second LED. So it seems to work fine. Okay, so now it's the time to test this machine. Welcome to the first demo flight of the Eachine QX110, the VTail. I made some little adjustment in terms of, for example, the minimum throttle. So when I was trying to arm, I found that the motor was spinning a little bit too fast, so I reduced to 170. Also adjust some little value in the level stress, and also on the rates I increase a little bit the rates. Okay, and now I will try more in lost condition and then more in FPV. Let's go. Okay, so I will power the machine, and when you plug it with the battery is much more louder, so it's a good news. Okay, it's only on the USB port that is weak. You can hear much better, no problem. Okay, it's armed. You have the Larsen scanner effect. I will record. I've got the OSD information. Yeah, let's go in 6-axis stabilized mode. Okay. Yes. The PIDs maybe can be adjusted a little bit. Yes. Not super stable. Yes, it's turning faster. Wow. Okay, I am not in full rate now. I'm in full rate. Let's see a pump. Okay, not so impressive. There are some bounce back, so probably some PID adjustment must be done. Okay, it's not super stable. But it's turning super fast. Yes, it's true that the yaw authority is much better. Oh. Okay, so let's see now in FPV.